Imagine the loneliest place in the universe. No, not a desert, not the bottom of the ocean. Imagine a place where the nearest star is 40,000 years away. A place where the wind that blows is made of the ghosts of dead stars. A place where the temperature hovers just 3 degrees above absolute zero. Now imagine that we sent 2 robots there. Not with warp drives or laser cannons, but with 8-track tape recorders, computers less powerful than your car keys, and a golden phonograph record. This is the story of Voyager. In the summer of 1977, humanity launched 2 Titans, Voyager 2, and a few weeks later, Voyager 1. Their official mission was to explore Jupiter and Saturn, but their secret destiny was the edge of everything. For decades, they did the impossible. They revealed Jupiter's raging red storm as a complex hurricane. They flew through the geysers of Enceladus. They showed us the hexagon on Saturn's pole. But then, the planets ended. The mission clock ticked past the 20-year mark. The outer planets shrank to pinpricks, and the Voyagers entered a realm no physicist could fully predict. A place called the termination shock. You see, our solar system isn't empty. It is filled with the sun's breath, a supersonic wind of plasma and charged particles called the solar wind. This wind blows outward at 1,000,000 miles per hour, creating a bubble around our planets called the Heliosphere. Scientists believed this bubble would simply fade away, like smoke dissipating in a room. They were wrong. Between 2004 and 2007, the Voyagers hit a wall. The solar wind, which had been screaming outward for 4.5 billion years, suddenly slammed into an invisible barrier. The particles didn't just slow down, they collapsed. The spacecraft recorded a sudden, violent surge in magnetic pressure. This was the termination shock, the point where the sun's wind finally crashes into the interstellar medium, the gas and dust between the stars. But the shock was not smooth. It was violent, chaotic. Voyager 2 crossed it at least 5 times, bouncing in and out of the heliosphere like a cork in a maelstrom. The first shocking discovery? The edge of the solar system isn't a line. It's a foam. A frothing, boiling border where the laws of physics break down. But the real shock was still coming, and it would take another 8 years to arrive. By 2012, Voyager 1 was 121 astronomical units from Earth. That is 121 times the distance from the Earth to the Sun. A radio signal traveling at the speed of light took 17 hours to reach it. The team at NASA's Jet Propulsion Laboratory was looking for a sign that Voyager had finally left the Sun's influence. They were looking for a change in the magnetic field. They assumed that the magnetic field inside the solar system, the heliosphere, would point one way, and the magnetic field outside, interstellar space, would point another way, like crossing a river into the ocean. But in July 2012, Voyager 1's instruments went quiet. Not broken, not dead, quiet. The density of the plasma around the spacecraft began to rise, slowly at first, then dramatically. The vibrations of the plasma, like a ringing bell, told the scientists a terrifying truth. On August 25th, 2012, Voyager 1 detected a 1,000-fold drop in the density of solar wind particles. The wind had stopped. Completely. Voyager 1 had crossed the heliopause, the true boundary of the solar system. It was now sailing in interstellar space. But here is the shocking discovery, the one that broke the models. The magnetic field didn't change. edged. For decades, astrophysicists had predicted that crossing into interstellar space would be like walking through a doorway. You would feel the shift. You would see the magnetic compass spin. But Voyager 1 found that the magnetic field of the Milky Way is almost perfectly aligned with the magnetic field of the Sun. It was as if the Sun's influence reached out, grabbed the hand of the galaxy, and shook it. Dr. Ed Stone, the project scientist for 50 years, said, "Nature is different from what we imagined." Voyager had discovered that the edge of our solar system isn't a shield, it's a membrane, and it is leaking.
Let's go back to the drawing board. Before Voyager arrived, every astronomy textbook included a feature called the bow shock. Here's how it worked. Imagine a speedboat moving through water. The boat pushes a wave in front of it. Our solar system is moving through the Milky Way at 56,000 miles per hour. Scientists assumed that as the solar system plowed through interstellar gas, it would create a massive supersonic bow shock, a wall of compressed plasma stretching billions of miles ahead of us. It made sense. It was elegant. It was wrong. When Voyager 2 crossed into interstellar space in 2018, it looked for the bow shock. It listened for the crash. There was nothing. Silence. The shocking truth? The interstellar medium is moving slower than we thought. Or rather, the solar system is moving slower relative to the gas. There is no bow shock. There is only a gentle bow wave, a ripple so faint it barely registers. The solar system is not a speedboat crashing through the ocean. It is a hot air balloon drifting through fog. This discovery forced astrophysicists to rewrite the textbooks. The edge of the solar system is not a violent collision. It is a quiet merging, a cosmic sigh. But perhaps the most haunting discovery has nothing to do with magnetic fields or plasma. It has to do with distance. As Voyager pushes onward, the sun's light is fading. The sun, which is a blinding inferno to us, is just another star in Voyager's sky. It shines with the brightness of a distant street lamp. But the cold out there isn't the empty cold we imagine. The Voyagers discovered a region of intense pressure. For the last 5 years, the probes have been sending back data on galactic cosmic rays. These are atomic nuclei, iron, carbon, oxygen, that have been accelerated to near light speed by exploding supernovas millions of years ago. Inside the heliosphere, the sun's magnetic field acts like a bouncer, deflecting most of these deadly rays. But at the edge, the bouncer is off duty. Voyager has recorded a 20% increase in the intensity of these cosmic rays. These are bullets of pure energy. They pass through the spacecraft like it isn't there. They are slowly eroding the electronics. This is the 40,000-year wall. Even at 35,000 miles per hour, it will take Voyager 1 40,000 years to get within 1.6 light years of another star. It will fly past an obscure star in the constellation Camelopardalis, called AC +79 3888. By then, the plutonium powering the craft will have been dead for 39,900 years. Voyager will be a ghost ship, silent, frozen. But here is the shocking discovery that keeps scientists awake at night.
Even though the power will die, we only have a few years left to talk to Voyager. The probes themselves will continue flying for 1 billion years. 1 billion years. Humanity will be gone. The continents will have shifted. The sun will have grown hotter, boiling the oceans away. But Voyager will still be there, drifting in the dark. And on that craft is a map A map showing the location of Earth relative to 14 pulsars. It shows the frequency of hydrogen, the most common element in the universe. The Voyager team knew that the edge of the solar system wasn't just a physical boundary, it was a temporal one. They built a time capsule for a civilization that does not exist yet.
In 2017, scientists published a paper analyzing the plasma waves around Voyager 1. Plasma, when it vibrates, produces a frequency. If you shift it into the human hearing range, it sounds like a whistle. For years, the whistle was high-pitched. That was the sun's wind. But when Voyager crossed the heliopause, the tone dropped. It dropped by a third. Listen. That is the sound of interstellar space. That hum is the vibration of the gas between the stars, the gas that fills the galaxy, the gas that will eventually collapse into new stars and new planets. Voyager didn't just find the edge of the solar system. It found the womb of the galaxy. That low, constant hum is the background radiation of the Milky Way. It is the sound of the universe breathing.
Before Voyager left the neighborhood of Neptune, Carl Sagan convinced NASA to turn the camera around, to look back. They took a photo of Earth from 3.7 billion miles away. In that photo, Earth is a single pixel, a mote of dust suspended in a sunbeam. That photo is the true shocking discovery of the Voyager mission. Not the missing bow shock, not the aligned magnetic fields, not the humming plasma. It is the realization that the edge of the solar system is not a wall. It is a perspective shift. Voyager taught us that the boundaries we draw between sun and star, between solar wind and cosmic ray, between home and the void, are human inventions. The universe does not have hard edges. It has gradients. It has whispers. It has slow, quiet transitions that take billions of years.
Today, as you listen to this, Voyager 1 is 159 AU away. Voyager 2 is 133 AU away. Every day, they get 900,000 miles further away. Every day, their signal gets fainter. By 2030, we will likely turn off the last instruments. By 2036, they will be out of range of the deep space network forever. But before the microphone goes dead, Voyager will send one final data packet, a final whisper of voltage, and then silence. The shocking discovery at the edge of the solar system is that the edge doesn't exist. There is only the journey. And for 44 years, two little robots built in the 1970s did what no empire, no religion, no philosophy has ever done. They reached the void. They looked into the abyss, and they called home to tell us what it felt like. This is the true story of Voyager, the mission that went to the edge and found only the beginning.